time complexity and space complexity. In this video, we are going to learn about this. It is one of the very important topic while you are writing any algorithm. Let's say in beginning you will write some sort of beginner level like a brute force method where the time complexity can be big O. You might have heard like that big O for n, b o go big O of n square. You might have heard what are this and how this thing makes an algorithm better and how we can say an algorithm is bad. That's today we are going to see. Using this time complexity and space complexity, we can say whether an algorithm is good or bad. So let's begin with this. I'll give you an example, small example, before starting into the definition of time complexity and all. Let's say there are two friends, A and B. B and A, they are given a problem statement where there is some size of 10 inputs given to each of them, and now they have asked to write a code that solves that problem. Now A wrote a problem solution for the problem same as B, but the time taken for each of them is changed. Like the algorithm took 2 seconds for A to solve that problem, whereas the algorithm took 10 seconds to solve that problem for B. Now I'll ask which algorithm is better. We'll definitely say that this algorithm is better, right? Yeah, that's true. Now we can see that like one problem, multiple solutions are there, right? Solutions are so many. So, so whenever you will start writing a like solution for a problem, you'll see that yeah, I wrote a solution. Now it's giving me answer. It's correct. Yeah, it's correct, but it's not efficient. There is a difference between a correct and efficient like solution, right? Both of them are solving the problem, but this one is efficient problem, and this makes a programmer a good programmer. Now we'll see time complexity. This is what I wanted you to know before diving into it. Now we'll see what is time complexity. Okay. Now let's say for example, as I have mentioned there, like they were giving 10 inputs as a value. Like this is the data or the value of 10 given to them, like that. If we increase this, we make the 10 to 100 inputs, 100 values. Is it going to behave like that only? Is it going to behave like is it going to be constant? Is it going to be take 2 seconds only, or the time complex this time will also increase? Will it become like 3 seconds or 5 seconds, like that? So the change in the input, change in the input, how it behaves in that time, how it is behaving, the algorithm is behaving. That is what time complexity is. For simple term, let me write it down here. Change in behavior of an algorithm as per increase in input. Okay. Now that change is called time complexity. Now time complexity is not measured in seconds. Okay, time complexity is measured with big O of notation, big O notation. Now there are multiple things: worst case scenario, best case scenario, like average case scenario. But we always take the worst case scenario. How wrong can this code can go? That is the limit. This is the limit the code can make worse. Beyond that, it's not going to be. Okay. See what I am going to write something here. means big O, big O notation. Okay, big O annotation. Okay, see, let's say we have a code like this, like a for loop. Int I is equal to 0, I is less than 5, I plus plus. Okay, now we know this for loop will go till 4, like till 4, like I when I becomes 4, it will stop and it will leave. Okay, in time complexity we do not measure the seconds. What we measure, we measure the operations it's going to take. How many operations this will do? It will run the operation in 0 0. Okay, it will run in 1, it will run in 2, 3, and then 4. At 4 it will check again. When it will become 5, it won't run, it won't complete that operation, it will move out. So till this it's going to run, means 1 2 3 4 5, 5 operations are there, right? 5 operations means this is n. Let's say this is n, means n operations making. So what we say, big O of n is the time complexity, means this much operation it will do, because till I becomes 4, it won't stop, it will do the operation, it will keep doing that until and unless it is 4, it won't stop. But let's say for example if it gets stopped here itself, so we will say this much, this is the n, this is won't be going to that. Now let's say it becomes 500, now n becomes 500, so it will go till 500, so it is n, this is called linear, which is big O of n. Now there is one thing else, constant. Make sure time complexity is measured how many operation is done, not by seconds. Okay, this is very misconception, like conception. Like people think time complexity is being measured by the seconds. No, it is measured by the operations of algorithm does. Like for this case, for our case, in this for loop, how many operations are being done? 5 operations is being done, like from 0 to 4. So there is 5 operations. 5 times this for loop is running. So the time complexity of this for loop is 5. Whereas there is one more code where is the same thing is done by another code, another algorithm. The operation for that is taking 10 times. The same thing is being done 10 times. I don't know how it's happening, but it's happening 10 times. Then we will definitely say the big O of n is this, means worst to worst it will become this. The best case would be big O of 1 or omega 1, something like there is something like that as well. Okay, this is called constant. At first go only you'll get the answer solution to it. This is what best case scenario, this is the worst case scenario, it will go till 10, no matter what it will go till 10. Now where the best case scenario comes, I'll show you. I'll tell you something that like for example in array itself there are multiple things, like first is constant, which is big O of 1. Second is linear, which is big O of n. Third, quadratic, n square. Then fourth we have big O of log n. Fifth we have There are more as well like this. I'll also tell you. I'll tell you first one. This one. This, when we say, when we do operation in array to fetch a, let's say this is an array, 1, 2, 3, and 4. We want to fetch this one, this value. This is 0 and this is 1, 2, 3. The indexes. This is indexes, right? You remember that? Okay. So we are trying to fetch array 1. Is it going to use any for loop for this? No for loop. There is no linear, like it won't go it won't start from here, right? It won't start from here. It will directly go. This is the beauty of array, that it will directly go and it will fetch this value directly, because we have mentioned here one go array, go to the value variable array and fetch me the index 1. So it will go here and it will directly fetch this index and give me the output or 2, no matter whether how many values are there. If it is right now it's 5, let it be there are thousand of values. Even then it will it won't traverse to whole array. It will directly go to that one index and it will fetch me the data and it will come back. That's what is big of one. Even here also, if I ask go get me the index 800, it will directly go to that index and it will bring me back. It won't it won't start from the index 0 to index 700 or 799 till then it will go to 800 index. It's not traversing like that using for loop. There is no for loop for getting data from the array index. It will directly go and it will bring me back. That's what is big O one. It's constant. It's always constant. It's always same. It won't as the input is increasing. Like see, input is 5 and input is 1000. The input are increasing, but the time complexity remains this. That's what constant is. But what is linear? Linear, see, as the input is increasing, let's say the same thing, we want to get here. Here we have 5 inputs and here we have 1000 inputs. At 4 we are fetching, let's say we are fetching this value, second value we are fetching, right? Okay. Okay, so we are fetching second value here. We are fetching this second value, this 3 value we are fetching here. Okay. So for linear, what it's going to be, for linear, it will start from here. It will go to 0, then it will go to 1, then it will go and it will check the yeah, I'm in index 2. Now I need to fetch this one. So it is traversing here from started from 0 to 2. So the operation is also increasing here, right? As you can see, operation 1, operation 2, operation 3. Now time complexity becomes big O of 3 here and here as well. Now we want to fetch the index number 800. So it will start from 0 till 799 till 800. It will go 800. The operation is also increasing here. Means, can you understand? Input increased, time complexity, which is our operation, also increase. This is called big O of n. This is what linear. This is what linear. In previously in constant, what was happening? Time, this input is increasing. Input was increasing. but no change in the time complexity. It was directly going and it was fetching me that data. But in linear algorithm, what is happening? It is traversing whole array to till that value. So we go and now here it is 3, so it's traversing everything till this. It will go and it will give me that value. So that's bad, right? Yeah. Now there's one thing, quadratic. Let's say we right now we have one array. We had one array. What if it is multiple array? Like multiple, it's a matrix. It's a matrix like this. It has column and row. For example, we'll use normal for loop is linear. When we have like this for loop, inside again we have a for loop. Now this first for loop is taking big O of n. This inner for loop is also taking big O of n. So what? And we'll multiply this whenever anything is in nested. We do multiplication. So n square. So it becomes big O of n square. Okay. Where else? Where else? Let's say it's like this. If it is like this, for loop and sorry, let me clear it out. Let's say we have like this for loop and we have another for loop, outer for loop as well. Now this is big O of n and this is big O of n. When there is no nested but they are both in outer way, then what we do? We addition. We add big O of n plus big O of n. Now what it becomes? 2n. And in time complexity, we remove the constant. Constant is no of use. So what it remains? It remains n. So now it becomes big O of n. At this point of time, it is big O of n. To remove constant, we do not consider any constant. And let's say, for example, there is two operations. Here is one big. These are some conditions you need to remember. This one. There are two conditions here. Let's say this algorithm is taking this code is taking big O of n, and this is something that is taking big O of log n. Okay, now for this I need to tell you that ascending order of this algorithm. I'll tell you that, then I will come this back. Okay, till also let me complete this. Here, let's say we'll add because these are outer. These are not nested. So we'll do like this: big O of n plus big O of log n. Here what happens? Which one is greater? Which one is more time taken? This is much time taken than this. This is bigger than this value is bigger than this. So what we are going to neglect this one and we'll keep this one. So we'll conclude that the whole time complexity will be big O of n because the whole code is going to be worst case. In worst case, it's going to be big O of n because this is the worst than this. This is better one. Log n is better than this linear. So we'll consider the worst case and we will say big O of n. Okay. Now we'll see something else. I'll list that down. First one is ignore constant. Then we have ignore less valued time complexity. Then we have we need to keep the dominant. Oh, yeah, these two is enough itself. Like both the same thing. Dominant one means the better, that more worst case scenario. We need to keep this one. You need to remember these two things, and you will remember that one. Like when nested, we do multiplication, nested for nested, for outer, addition. Okay, this is the some process. By doing this all, we can say, we can conclude that how a code or an algorithm behaves, like the time complexity of an algorithm. That's what it is. Let me show you something here. This is something, and yeah, array access. When we do access in array, this is what there are some. These are some time complexities, and where they all, no. Do not. These are different thing. Okay, they're different thing. These are some examples you need to see, and there are some examples as well. Mm, for single loop interchange. Okay, do not compare this. So these are few operations, and these are the time complexity. Complexity operations. Okay, or algorithms. Array access, when we access an array, it becomes constant. For linear search, it is big linear. This one is big O of n. This one, let me write it, big O of 1. Then this one is linear search, big O of n. For binary search, it is big O log n. What is log n? What is log n? Log n means, yeah, it's, I need to explain you this one also. See, log n is somewhere, let's say in dictionary, what we do, for, let's say you are finding one word in dictionary, you are not going to search everything. It's really good, from the start page till that that word, until you get that word. We are not going to search the whole thing out, right? You are going to take one page in between. You'll have, you will open a dictionary and you make a half of both sides. Then you'll see which, where I am. Then you'll check whether in ascending order, whether the word will be in the left hand side or right hand side. If that direction you will go. Again, you will make a division. You will divide them, that part, into two, and again you will compare where I need to go, left or right. Let's say you are going to left, then you will go to left side. Again, you will divide it till you are going to do this thing, this dividing the uh, dividing the part into two halves till you get your word. This is what log n is. Let's say this is an array, 1 2 3 4 5. Let's say we want to find 3. So what we are going to do, we'll first divide it. We'll, no, like, let's say we are going to find 4. Yeah, at 3, at first half only. First we'll divide it in an equal half, so we'll get the 3 in the first move itself. But we want to, when we want to find this 4, let's say we want to find 4, so we'll do division. We need to find the mid value of this. Means we'll count it and we'll divide by 2, so it will go give us this index 0 1 2. It will go give us the index value 2. We'll go here whether 2 is less than or greater than 4. 2 is less than, so we'll go to this hand side. This hand side we'll divide this again. So now this mid is in pointing to 4, so we'll stop this the index. So till we get the value, our wanting value, we'll divide the array into halves, two halves. That's what log n means. Log 2 means we are dividing it till we get this value, like that, equal to 8, something like that. It tells like we'll keep dividing, single loop is big of linear search of single loops, and same thing, right? Nested loop is big of n square. Merge is n log n. This is log n, like 2n. Bubble sort, it takes log n, n cube something, I guess cubic. Recursive example, factorial. This one is factorial for recursive. Okay. You can just go deep dive into this thing, you will understand in the flow. No need to be very much worried about it. Just keep in mind, just start digging into it. No need to go read everything again and again. No, start working, start solving problem. Go to LeetCode, go to hacker rank, and start solving problem. You will get it. Space complexity. Recently, we have learned what is time complexity, how to optimize our code, but while optimizing it, while improving the algorithm from, let's say, for example, from from n, from big O of n to making it big O of 1 or log n, we need to make sure that the space complexity is also handled. Now, there is something like space complexity has big O of 1, big O, similar to time complexity, it has big O of 1, then n, then also it has big O of log n, big O of n log n. We will learn this one. Now, mostly these two are used. This is also used, but most likely I will be explaining you what this thing do, these two. Okay. Let's say, for example, there is one thing called total space complexity. Total space, sorry, let's say total space means the input we are providing to a for loop. Let's say there is a for loop, and we are providing some input to it. That input plus the auxiliary space. What is this? This is it's the extra space taken by code. Okay, this is the extra space. And input uh, input can be like variables where the values are stored. This plus this is just total space. Input can be then something that is provided by parameters, like the values which are provided. And yeah, okay, see, I'll show you. Oh god. Space complexity. Recently, we have learned what is time complexity, but let's say we have a code and we are improving it. We are making a code from a big O of n to making it big O of log n. While making this thing, we also need to make sure the space complexity is also being maintained. Means, let's say most likely most of the time it remains big O of 1, which is constant. It won't take extra spaces or more spaces, but also sometimes it becomes big O of n. These two are most commonly being used. this is the most commonly seen. There is also called log n, similar to our time complexity, big of n log n. Okay, but there is a catch. I'll tell you this thing. Space complexity is something that it tells how much space required to run on a code, like while code is running. Okay, see, for example, let's say the total space, we can conclude that total space is consist of, like, the input we provide, the extra space it use, then we have the function calls. You'll ask me how these function calls are working. See, when you call a function, let's say we are running a code and we are calling a function, that functions are stored in a stack, like function 1, function 2, function 3. Later, when this function 3 will come, gets over, it will come out, it will go to function 2, it will go to this is what function call is. Recursion functions also works like this. So this is what it is. And extra space, see, this is what total space is. It can be, yeah, it can be big of 1 or big of n. Now I'll tell you what is how 1 and how n. We are running a for loop. We are running a for loop, like in I equal to 0, I is less than array dot length I plus plus. Means it will, there is only one variable. Now this is what the simple thing. And in sum, we have a sum. There are only two value. There are two value here. I, there are two variables, like I and sum. These two are the only variable which is being used in this whole for loop, right? There is another any other variable can you see? No, there is no another variable. There is only input and this variables. Now let's say this length of it is currently it's 5. Okay, so there is one variable, but when we add and we sum up, the same thing, there is only integer, so it will going to take only one variable and one sorry, this one variable I and sum. Let's say now it is now it's 5, so let's make it like 100. Even in 100 size of input also, the variable will be the same. The space it's going to take is the same, which is constant. This is what auxiliary space. This extra space are called auxiliary space. Okay, no matter how the input size is, but it's gonna take the same variable, which is constant. Okay, so this is the auxiliary space. Means the extra space which is being taken uh, by the code. Okay, now how can it become log big O of n? Let's say for example we have another for loop. I'll write it in better way. I equal to 0, I is less than array dot length I plus plus. Here what we are doing, here we are gonna create a new array. We'll create a new array list or something like that. Let's say we are creating an array list, list dot add array I. So what happening here, we are creating a new array. We are storing 1 2 3 new array. The size of this is like till 4. The size is also 4, and we are storing all the value of that 4. So what happening here, as the input size is increasing, the space is also increased. If you make it 100, here it will become till dot 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 100. See, input uh, input is directly proportional to the output, which is equal to output space, in the sense space. Okay, cool. So at this point of time it becomes big O of n, because the input is increasing, input increases, the space also increases, because space means this array list also increasing, input is increasing. This is big O of n. This is what you need to make sure that this is how you need to handle everything up. So this is what space complexity is. You can little dig more into this. You can read some articles from Gigs for Gigs, which is very much important as well, to make the things much clear, and which will be easy for you to solve any sort of questions from LeetCode, hackering, or Gigs for Gigs. Thank you.